Hello, my name is Naiman Khan. I'm a postdoctoral research associate at the University of Illinois. I work in a laboratory called the Neurocognitive Kinesiology Laboratory. The director of the laboratory is Dr. Charles Hillman. And our laboratory studies health behaviors, particularly physical activity and nutrition, and how it relates to cognitive health in children who are prepubertal. So most of our participants in our studies are between 7 to 10 years of age. And the data I'll be presenting today we'll be discussing some of the data that we have on physical activity provision. Does providing children with physical activity on a daily basis improve their cognitive function over a 9-month period? I want to first point out a very important message here is that physical activity has been declining in children in the United States and much of the Western world. This is some data that shows that children, as they get older, tend to be less and less physically active. In fact, the greatest proportion of children that are meeting their physical activity requirements are only about 50%, and that's between 6 to 11-year-olds. And after that, that significantly drops to about 10% for 12 to 15-year-olds and then 16 to 19-year-olds. So we essentially see a really tremendous decline in physical activity among prepubertal children. And really the recommendations are not too difficult to meet. It's really an hour a day of moderate to vigorous physical activity. So what you're basically saying is that children are not physically active. And this is problematic because we know that physical activity is related to health benefits, cardiovascular health benefits, as well as reduction in risk for obesity, and a host of other health factors. Our laboratory is interested in saying what sort of effect is this inability to meet physical activity guidelines, or even providing physical activity, how does this affect aspects of cognitive function? So the specific aspects of cognitive function that our laboratory studies are called cognitive control or executive function. And these are a set of core functions that are essentially involved in the ability to orchestrate thought and action in accord with internal goals. So these are processes that are involved in planned action. And they're very important functions. There are three core functions. There's one's called working memory, the other is inhibitory control, and the third is cognitive flexibility. And together these core functions essentially underlie higher order functions that are very important, such as reasoning, problem solving, and planning. And of course they're also important for the acquisition of knowledge and the retention of knowledge, so they have an important role to play in academic achievement in children. So to understand the factors, particularly how physical activity affects cognitive function and specifically cognitive control in prepubertal children, we have conducted a randomized control trial that assessed whether providing children with physical activity on a daily basis for just at the level at which meets their daily requirements, if that actually helps them get better in cognitive function tasks in relation to a group that's not receiving that exercise for a year. So this is data from our trial called FIT-KIDS. It's a randomized control trial. FIT-KIDS stands for Fitness Improves Thinking in Kids. It's a 9-month after-school physical activity research trial. Recently concluded. We were able to enroll 220 children, and we randomized them into an intervention group and a waitlist control group. The intervention group received a physical activity intervention for the 9-month period, 5 days a week at a level of 70 minutes of moderate to vigorous physical activity. And the curriculum for this intervention was adopted from the coordinated approach to child health, what's called the CATCH curriculum. And here what you're seeing is that the physical activity intervention of course also provides other benefits other than cognitive function, and we'll get into that in the next slide. But first I want to point out that in this data slide you can see a comparison of the waitlist participants and the children in the intervention group. And you can see the children in the intervention group following the 9-month intervention exhibit greater changes that are positive in VO2 max, which is a gold standard measure for aerobic fitness. And they also show greater reductions in percent body fat relative to the waitlist group. In fact, the waitlist group actually shows increases in percent body fat over the 9-month period, which suggests that not providing children with structural physical activity programs that may actually increase the risk of children gaining excess body fat. And you can see in this trial, through the intervention, we actually see a reduction in body fat gained among the intervention participants. So we know that our intervention is working because it is making children fitter, and they are maintaining a healthier body composition as a function of the intervention itself. However, our main interests are in how this affects cognitive function, and if exercise provision does improve cognitive function in children. So this data slide shows you a comparison of the waitlist group and the intervention group here on the left of the bar graphs. assessing the accuracy of the groups on an attentional inhibition task and a cognitive flexibility task. And these are these two tasks are designed to tap into aspects of cognitive function, specifically cognitive control. And what you can see is that in attentional inhibition and cognitive flexibility, the intervention group shows greater significant positive gains as a function of the 9-month physical activity trial. And in addition to behavioral assessments of just accuracy, our laboratory is also able to assess what are called event-related brain potentials. And these are essentially, these are components of the EEG that we can record on the scalp, and they're thought to reflect specific cognitive processes. So these are voltage deflections that occur in relation to specific cognitive processing during tasks, and we can see, we can compare how the changes in voltage deflections on the scalp relate to particular cognitive processes. So during these tasks, these children are also wearing EEG caps, and we could be able to collect EEG data. And on the right here, you're looking at what are called topographic maps of the differences that are occurring between pre and post-test on two tasks, which one is the flanker task and the other is the heterogeneous trials of the switch task. And what you're seeing on the left is the intervention group, on the right is the waitlist control group. And these are changed maps of topography on the scalp. So what you're observing is that there are greater changes indicated by the darker, the more red the scalp map is, that indicates greater positivity. And you can see there's greater changes that are occurring in the intervention group versus the waitlist group, specifically for a component that's called the P3. The P3 is an ERP component that indicates or is thought to reflect, whose peak is thought to reflect attentional resource allocation. So the larger the peak of the P3, it's thought to suggest that the child or the participant is dedicating a greater amount of attentional resources during task execution. And so you can see here that not only do children in the intervention group do better on the behavioral, on the tasks in terms of behavior, in terms of accuracy, but we see greater positive changes in their attentional resource allocation during these tasks, particularly for the more difficult versions of these tasks, which are such as the incongruent trials of the flanker task and the heterogeneous trials of the switch task. So in overall conclusion, what our study was able to show is that providing children physical activity over a 9-month period at a level of about 70 minutes per day of moderate to vigorous physical activity improves cognitive function in children between 7 to 10 years of age. And we see this not just in terms of accuracy, but we also see changes in brain function that change in relation to the provision of the physical activity. I wanted at this stage also acknowledge our team of researchers who conducted the study, including the investigators, Dr. Charles Hillman, Neil Cohen, and Arthur Kramer, as well as the granting sources. Our trial is funded by, the FICKIDS trial is funded by NIH, but we also have staff that's funded by USDA funds. And this is a photograph of our research team that worked in the FICKIDS trial. FICKIDS is actually one of the first trials that's shown that provision of physical activity in a randomized controlled trial setting can actually improve cognitive function in children. So now that we know that physical activity, or children just meeting regular daily requirements of physical activity can actually improve cognitive function. So our laboratory primarily works with this age of children because there's not a lot of literature in this age. This is the middle childhood period. There's a lot of data among adults that has shown that providing physical activity improves cognitive function, but it hasn't been shown consistently enough in children, especially younger cohorts of children. So that's why our laboratory focuses on this age group. But we also are, because cognitive development is occurring in these children, different age groups function at different levels. So it's difficult to have studies that overlap, several years of the childhood development, because you're essentially comparing children that may be years ahead of the others in terms of cognitive development. So we focus on a specific range of children.